let's determine the electric field for a line with a uniformly distributed charge at a point P that's collinear with this line and at a distance d from the line. Well, again, we take our differential charge element and we take it at some distance x from the start of the line. So this is our origin x equals 0, and this here is x equals L, where L is the length of the line. So now using our differential electric field that's going to be produced at this point, well, because we have positive charges, so our differential electric field vector is going to be pointing away from the line. So what we have is the magnitude of this electric field vector is equal to 1 over 4 pi epsilon naught by the differential charge on the squared distance from this element of charge to this point where we want to determine the electric field, which is x plus d squared. And the differential charge can be taken as the linear charge density by the differential dx along this line. So therefore we get 1 over 4 pi epsilon naught multiplied by lambda dx on x plus d squared. And that's equal to dE, and then integrating both sides of the equation, we obtain the magnitude of the electric field at this point over here is equal to lambda on 4 pi epsilon naught by the integral over x, and we're integrating x plus d squared. And we integrate from x equals 0 to x equals L. And now using trigonometric substitution, we can let u equal x plus d, and therefore du is equal to dx. So we can rewrite the integral as du on u squared, which is the same thing as the integral of u to the negative 2 over u. So that would give u to the minus 1 over minus 1 using the power rule for integration, or minus 1 on u. So therefore we can write this as lambda on 4 pi epsilon naught, and the integral evaluates to minus 1 on u, and if we back substitute for u, we have x plus d, evaluated from 0 to L. And therefore we get lambda on 4 pi epsilon naught by minus 1 over L plus d minus negative 1 on d. And now let's continue our calculation over here. So we have lambda on 4 pi epsilon naught, and if we cross multiply, we have L plus d minus d over d by L plus d. So the d's cancel, and we have lambda L on 4 pi epsilon naught multiplied by d by L plus d. And we can recognize that lambda L is the total charge along that line. So that would be q on 4 pi epsilon naught by d by L plus d. And that's another expression for our electric field. And we can observe that as the length of the line goes to 0, we get a d squared term in the denominator, and the distribution of line charges behaves like a point charge. And I'll see you in the next video.